These days, more companies are investing in autonomous vehicles. From ride-sharing services like Uber to large auto manufacturers like Audi, the industry is booming. Despite growing interest, the technology itself is in a proof of concept testing stage. It's smart, but engineers are working to make it smarter. Turning a manually operated car into an automated one requires data to be acquired and processed the same way humans innately do. Every day, we interact with the environment through sight, sound, and touch. To drive a vehicle, we are also guided by backup cameras and side and rearview mirrors, and by sensors that monitor road conditions and activate our brakes accordingly. The human gives all the gathered data to the brain to process this information and make decisions. Cars must have sensors that can produce such data, as well as smart methods to process the gathered information. That's where signal processing comes into play. Signal processing is about analyzing data and making decisions. To provide very detailed maps of the area surrounding a vehicle, autonomous cars utilize LiDAR or radar sensors. These LiDAR and radar sensors produce vast amounts of data that is then processed in real time. The challenge is in using this data to help the vehicle make decisions just as we would if we were behind the wheel, if not better. Humans understand red means stop and green means go. We recognize and understand a yield sign. We know to pull over if we see and hear police sirens. We understand the context surrounding driving. Autonomous vehicles have to learn these rules, but they also have to learn the skill of prediction, critical for preventing accidents and for smooth and seamless autonomous driving. As humans drive, we predict what drivers and pedestrians are going to do next. We constantly assess the risks and hazards and try to minimize accidents. An autonomous car must do the same. Autonomous cars need to merge multiple types of data from many sensors that allow for fast object recognition, as well as develop the reasoning that translates data and object recognition into contextual understanding from which decisions can be made. Predicting the behavior of other drivers, bicyclists, pedestrians, and hazards should be integrated into decision-making. The promise and success of autonomous vehicles is tied to being able to analyze many data types, more than we have as drivers, to yield better decisions. Signal processing engineers provide these methods to autonomous vehicles. All of our driving decisions are done individually, but with autonomous vehicles, the decisions being made can be distributed and coordinated. It's possible that someday cars and even the road will be able to share data with each other. Road sensors could tell your car there are icy conditions ahead, so it automatically adjusts the way it drives to have smarter and better road traction. It's even possible that fleets of vehicles could coordinate the distances between each other automatically to optimize traffic flow, reduce fuel consumption, and lessen the risk of car accidents. We've come far and have even farther to go, but with signal processing engineers behind the wheel, we can visualize a not-so-distant future when we'll all be letting our cars do the driving. Will you accelerate us into the future of driverless cars? Learn more